Calculus is a journey of discovery. 1 year to master the language of change. Are you ready? Let's begin.
Okay, we are now in 1 year calculus week 9. This video is solution for 1 year calculus week 9. This week, we were asked to find the slope of a tangent line at a point. Okay, in most cases, you are given an explicit function, that is y is equal to f of x. But in this case, you are given an implicit function where y and x they are intertwined into a single expression. And that expression is x minus y ln y plus root 3 is equal to pi over 3 plus tan x, where x and y, the variable x and the variable y, they are all together, that mixed together into one expression. And we have to find the tangent line at pi over 3, 1. This is when x is equal to pi over 3. That is when x equals to pi over 3 and when y equals to 1. That's what we have to find. So first of all, let me just make sure that this point is actually a point on this curve. To make sure that this point is a point in this curve, you substitute x equals to pi over 3, you substitute y equals to 1, and you should get equality. If there's no equality, that means this point is not a point on that line, on that curve. The points can be anywhere else in the graph. So let's substitute x equals to pi over 3. Then you have pi over 3 minus y is equal to 1. That is 1 times ln 1 plus root 3 is equal to pi over 3 plus tan pi over 3. Okay, ln 1 is equal to 0 because the natural log of 1 is equal to, in fact, the logarithm of 1 is equal to 0. No matter what the base is, the logarithm of 1 is equal to 0. So all this here is equal to 0. 0 times 1 is equal to 0. So you have pi over 3 minus 0 plus root 3 is equal to pi over 3 plus tan pi over 3 now. Pi is equal to 180 degrees. Okay, so pi over 3 is going to equal to 60 degrees. Tan 60 degrees is equal to the square root of 3. So here we have root 3. So after you have simplified, all you will be left with is pi over 3 plus root 3 is equal to pi over 3 plus root 3. As you can see, equality holds. And since equality holds, then this point is a point on that graph. On that curve, sorry. The point on that curve. So since that we have decided that this is a point on this curve, we can now find the tangent line. As I said before, the tangent line is just the derivative of that curve. So let's find the derivative of this curve with respect to x. And we're finding the y with the x. Good. Okay. For finding the y with the x, we are going to implicitly differentiate this expression. To implicitly differentiate, you are going to differentiate the left hand side and equate it to the derivative of the right hand side. So let's differentiate the left hand side. For differentiate the left hand side, we have derivative with respect to x of x minus y ln y plus root 3. Derivative can be shared among all the expressions. So we have the derivative with respect to x of x minus the derivative with respect to x of y ln y plus the derivative with respect to x of the square root of 3. The derivative of x with respect to x is equal to 1. Because we have x to the power of 1. Remember the sum. Bring down the power, that is 1, x. Subtracted by 1, that is 1 minus 1. Multiplied by the derivative of inner function. But there's no derivative of inner function here. So it's just going to be 1 times x to the power of 0. X to the power of 0 is equal to 1. So this is equal to 1 times 1 is equal to 1. So we have the derivative of x with respect to x is equal to 1. If you just don't understand this, I'll just say that the x over the x. The x of the dx cancel the x here. But I'm very sure that this is understandable, that the derivative of x with respect to x is equal to 1. So you have 1 here minus the derivative of y ln y with respect to x plus 0. Why is it plus 0 here? It's because there's no x here. So basically, whatever you have here is not x to the power of 0 because x power of 0 is 1. So what you have here is x power of 0. But then you bring down this 0, you have 0 times x to the power of minus 1. 0 times anything is 0. So that's 0 cancel out all terms here plus this root string. So that's what we have this root here. Let me just raise this plus 0 to avoid confusion. Now what we're finding now is the derivative of y ln y with respect to x. Good. Now to find the derivative of y ln y, you need to remember product rule. The product rule states that, let me write in blue. The product rule states that the derivative of u times v is equal to, you keep u constant, then differentiate v, plus you keep v constant, then differentiate u. And that's what we're going to use here. Since you have a product, u is equal to y and v is equal to ln y, then we can apply the this thing product rule here. We can apply product rule here. So I'll say let y equal to u and let v equal to ln y. Remember, we're differentiating with respect to x, but let this just be this. If y is equal to u and v is equal to ln y, then what we're looking for here is the derivative of u times v with respect to x. But remember, the derivative of u times v with respect to x is equal to u times dv du dv dx plus v times du dx. Are you seeing it? We have du dv divided with respect to x is equal to u times dv dx plus v times du dx. That last time I told you that the derivative of u times v is equal to u dv plus v du. But since now we differentiate with respect to x, the reason why that function is like that, so you can differentiate. In case you want to differentiate with respect to y, you can just divide all through by y. Divide all through by dy. So you have the derivative of u with respect to y is equal to u times the derivative of u with respect to y plus v times the derivative of u with respect to y. But since you are differentiating with respect to x, they are going to divide by dx. So you have the derivative of u v with respect to x is equal to u times the derivative of u with respect to x plus v times the derivative of u with respect to x. So we can proceed. Now, if y is equal to u, then dy over du is equal to, remember, the same thing happens to x here. You have dy du is equal to du over du, which is equal to 1. So that means dy is equal to du. So we have dy is equal to du. So you cannot divide both sides by dx. This implies that dy over dx is equal to du over dx. So we have dy over dx is equal to du over dx. So in this place, if you have du over dx here, we can just substitute here with dy over dx. Good. The next thing we need now is dv over dx. We already know what u and v is. We have u and v here. So what we need now is dv over dx. Let's find what dv over dx is. V is equal to ln y. Dv over dy is equal to 1 over y. I believe you already know this. Dv over dy is equal to 1 over y. Because if you have something like maybe y is equal to ln x, and if you change both sides, you're going to have dy over dx is equal to 1 over x. In this case, we have v is equal to ln y. We are differentiating v with respect to y. So that is dv over dy is going to equal to 1 over y. Previously, we are going to do it here again. Multiply both sides by dy. This implies that dv is equal to 1 over y dy. Then what do we do? Last of all, we divide both sides by dx. So that means dv over dx is going to equal to dy 1 over y times dy over dx. Good. So in this case, I have dv over dx. We can just substitute in 1 over y dy over dx. So instead of dv over dx here, just substitute in 1 over y dy over dx. So our complete expression for the derivative of u times 0, which is y over y times x ln y. That means the derivative of y ln y with respect to x is equal to u times 1 over y dy dx plus v times dy dx. Now with this information now, you can now put in your value for u, you can put in your value for v. If you put in your value for u, you're going to have y times 1 over y dy over dx plus v is equal to ln y plus ln y times dy over dx. The y in the numerator here cancel the y in the numerator here. So all you're left with is dy over dx plus ln y dy over dx. Okay? Okay. Since we are looking for the derivative of u times v versus x, you can now put in your value for u and v here also. And that is the derivative versus x of u is equal to y and v is equal to ln y. So the derivative of y ln y with respect to x is equal to dy dx plus ln y times dy dx. So instead of the derivative of y ln y versus x that we have here, I'm going to put in this expression. So we have 1 minus dy over dx plus ln y dy over dx. So all this here we can clean it. I would also like to show you a shorter method to solve this question. That is, we have the derivative of y ln y. Then you can also solve it this way. You have the derivative of y ln y with respect to x. This is equal to, you keep y constant, then differentiate ln y. If we differentiate ln y with respect to x, it's going to be 1 over y. But since we are differentiating with respect to x, we are going to just add the y over dx, y dx here. So anyway, if you have u here, you are going to have u over dx. If you have v here, you are going to have v over dx. If you have x here, let us say it was x here, you are going to have dx over dx. So you can just clean it up and just leave it the way it is. But since you have y here, you are going to have the y over dx. Okay? Plus, you keep ln y constant. Then differentiate y. You differentiate y normally going to equal to 1. But since you are differentiating with respect to x, you are going to attach the y over dx. After that, that will be 1 times the y over dx. I'm going to go over that again. You keep y constant, differentiate ln y. If you differentiate ln y, you're going to have 1 over y normally. But since you're differentiating with respect to x, you're differentiating y with x, you add that the y over dx. Then the second one, you keep ln y, then differentiate y. If you differentiate y normally, you're going to have 1. But since you're differentiating with respect to x, you're going to have the y over dx. That is, you attach the y over dx. So the 1 times the y over dx. But 1 times the y over dx is just simple as the y over dx. So you just add y over dx here. The same thing happens. 1 times 1 over y is not equal to 1. So 1 times the y over dx is also going to be y over dx plus ln y dy over dx. You can see that we have the same answer. The y over dx plus ln y dy over dx. We have the y over dx plus ln y dy over dx. Good and fine. Let's move on to the next part of the question. Are we through here? And we can simplify the thing further, actually. So let me do that. You know what? I'll just leave it like this. Let's get the same level from the right hand side. This now, all I've done now is for the left hand side. Let's do the same for the right hand side. For the right hand side, okay, for the right hand side, we have this is equal to the derivative with respect to x of pi over 3 plus tan x. This is not equal to the same thing happens. You can separate the derivative into the derivative of sums is equal to the sums of derivative, basically. So the derivative of this sum here is equal to the sum of each derivative. So we have the derivative versus x of pi over 3 plus the derivative versus x of tan x. This now we are going more straightforward than the other one. This is equal to the derivative of the constant is just 0, as I showed in the other place, plus the derivative of tan x with respect to x. Should I show this? I don't really want to, because this is already a standard integral. But if you want to prove this, then you change tan x to sin x over cos x. Then you use quotient rule. If you use quotient rule, you're going to have this thing. You're going to have sin square x plus cos square x in your numerator. Then your denominator, you're going to have cos square x. So we're going to do 1 divided by cos square x, which is equal to sec square x. Use first of all change tan x to quotient um to sin x over change tan x to sin x over cos x. Change tan x to sin x over cos x. Then differentiate sin x over cos x using quotient rule to get 1 divided by cos square x. 1 divided by cos square x is same times 1 divided by cos x times 1 divided by cos x. 1 divided by cos x equals sec x. So you're going to have sec x times sec x, which is equal to sec square x. So the derivative of tan x respect x is equal to sec square x. Let me want to explain something. If here you had y, instead of following all those processes I showed you here, you can just change here to sec square x, sec square y dy dx. Instead of following all the long processes that I showed here, you can just change here to sec square y dy dx. But now you're differentiating with respect to a function in terms of x with respect to x. That's why I differentiated this one now. We are going to add dx over dx. But since dx over dx is equal to 1, you can just clean it off and leave it this way. That's why most times just see it this way. You don't see the dx over dx. But if you add y here, this is just an assumption. This is not the question we are giving. But if you add y here, after you have differentiated and you get sec square y, you are going to add dy dx behind it. You are going to add dy dx behind it. But in this case now, since you are differentiating a function that is in terms of x with respect to x, you are going to have sec square x. They are going to attach dx over dx. But since dx over dx is equal to 1, you can just clean this off, and leave it like this. So now we have our full expression. We have 1 minus dy dx plus y by dx is equal to sec square x. Beautiful. Now what we are looking for is dy dx. That is our tangent, our slope function. Okay, we are looking for dy dx. What here hinders us to dy dx? You can say it's attached to plus 1. So let's first of all try to remove this plus 1 from here. And to remove this plus 1 from here, you can see that we can move these dy dx's to the right hand side. Move dy dx to the right hand side, you are going to add dy dx plus y dy dx. If you add dy dx plus y dy dx, everything here will equal to 0. So in the right hand side, we have dy dx plus y dy dx. Then you move your sec square x to the left hand side. So all you are left with is 1 minus sec square x. But 1 minus sec square x is equal to something. Dy dx here. But dy dx is in 2 terms. It's dy dx with 1 here and dy dx with ln y here. So let's factor out dy dx. So here we have dy dx. Dy dx divided by dy dx is equal to 1 plus dy dx divided by ln y dy dx divided by dy dx is equal to ln y. But basically just removing all the y dx from the function. And this here is equal to what? Tan square x. Okay. There's no more space on the board, so I'm going to clean our top layer. Let me get 2 lines from the top layer. Okay. So now we can now divide both sides by 1 plus ln y. So we have the derivative of y with respect to x is equal to tan square x divided by 1 plus ln y. But this is not a final answer. They did not ask us to find the derivative for all the points. They told us a specific point that we should find for, and that is pi over 3, 1. That's the point when x equals pi over 3 and when y is equal to 1. So you are going to put this here into the derivative function. So dy dx when x is equal to pi over 3 and y is equal to 1. The derivative is also equal to tan square pi over 3 divided by 1 plus ln 1. Dy dx at that point is equal to tan square pi over 3 is 60 divided by 60 degrees divided by 1 plus room y as we showed before is equal to 0. So 1 plus 0. This is equal to, then 60 degrees is equal to square root of 3. That's square root of 3 all squared divided by 1. And this is equal to 3. Because square root of 3 also is going to, the square and square is going to cancel out. So I'm going to have 3 divided by 1. And 3 divided by 1 is simply just 3. So the standard line at pi over 3, 1 for the expression x minus y ln y plus root 3 is equal to pi over 3 plus tan x. The standard line is going to equal to 3. So I believe that is the end of this question. See you in 10 1 year of calculus. If you have any contributory question that you want to see in the series, you can send it to akubigobk@gmail.com and your question will be show up on one of the weeks. But for now, we are going to use my own questions. See you next week. You can check out the question on IgweMatics.blogspot.com for the future updates. Thank you so much for watching. Bye bye.
Yeah, calculate. Check the variables, running up commas, that's summation. Solve for x, that's a new placement. The logic solid, every play is prime. Stacking these numbers, yeah, it's my design. All my moves connect like ordered pairs. Got the whole game mapped out on my graphs. Yeah.